Failure mode and effects analysis is a methodology that helps a product designer or manufacturer in identifying all possible failure modes of a product. At the time of product design, the design engineer conducts an analysis to identify all possible failure mode that a product may have during design, manufacturing, assembly and duration of its application. This analysis is known as failure mode and effects analysis, also known as FMEA. Before starting, let me introduce myself. I am an industrial and manufacturing engineer with specialization of Masters in Industrial Management. I have been working for more than 5 years teaching ways to improve quality, reduce wastages in a process, management on inventory, improvement of talk time, root cause analysis, etc. I will be teaching you this course. Let's get started. In this course we will study: what is failure mode and effects analysis? Types of failure mode and effects analysis. When to use failure mode and effects analysis. How to make failure mode and effects analysis. Advantages of failure mode and effects analysis. Explaining solved example of failure mode and effects analysis. FMEA is a tool that was developed by U.S. military in 1940s. Today this tool is very helpful to reduce the chances of possible failure of a product. When defining this methodology, it can be broken into two major parts. Failure mode. It's basically the errors, defects, or failures that could affect the customer, production, assembly or manufacturing in any way. These failure mode can be potential or actual. Effects analysis. It's basically the study of the consequences that could result in terms of the failure. It is a subjective screening tool that uses numerical assignments to determine the risk associated with each failure mode. The highest scored items add the highest risk to the problem or present the highest risk to the process, design, or function. Failure modes and effects analysis also documents current knowledge and actions about the risks of failures, for use in continuous improvement. FMEA is used during design to prevent failures. Later it's used for control, before and during ongoing operation of the process. Ideally, FMEA begins during the earliest conceptual stages of design and continues throughout the life of the product or service. Failure mode and effects analysis, FMEA, is a structured approach to discovering potential failures that may exist within the design of a product or process. Failure modes are the ways in which a process can fail. Effects are the ways that these failures can lead to waste, defects or harmful outcomes for the customer. Failure mode and effects analysis is designed to identify, prioritize and limit these failure modes. FMEA is not a substitute for good engineering. Rather, it enhances good engineering by applying the knowledge and experience of a cross-functional team, CFT, to review the design progress of a product or process by assessing its risk of failure. There are basically two types of FMEA: design FMEA and process FMEA. Design FMEA relates to the way that a system, product, or service was conceptualized. As the name suggests, DFMEA focuses on the design aspect of a developmental process. It is primarily beneficial in testing out new product ideas before introducing them to real-life scenarios. Design FMEA, DFMEA, explores the possibility of product malfunctions, reduced product life, and safety and regulatory concerns derived from material properties, geometry, tolerances, interfaces with other components and/or systems, engineering noise, environments, user profile, degradation, systems interactions. The nature of PFMEA differs slightly as it looks into current processes and procedures that an organization is already performing. PFMEA would typically address potential failures that can have significant impacts on usual operations. Some examples of business impacts are process stalls, human errors, and environmental and safety hazards. Because of its nature, PFMEA can be performed more effectively when historical data is available. Process FMEA, PFMEA, discovers failure that impacts product quality, reduced reliability of the process, customer dissatisfaction, and safety or environmental hazards derived from human factors. Methods followed while processing. Materials used. Machines utilized. Measurement systems impact on acceptance. Environment factors on process performance. There are several times at which it makes sense to perform a failure mode and effects analysis. When you are planning on performing an existing process in a different way. When you have a quality improvement goal for a specific process. When you need to understand and improve the failures of a process. When a process, product, or service is being designed or redesigned, after quality function deployment, QFD. When an existing process, product, or service is being applied in a new way. Before developing control plans for a new or modified process. When improvement goals are planned for an existing process, product, or service. When analyzing failures of an existing process, product, or service. Periodically throughout the life of the process, product, or service. Following are the steps for making FMEA. Step 1. Assemble a cross-functional team of people with diverse knowledge about the process, product or service, and customer needs. Functions often included are design, manufacturing, quality, testing, reliability, maintenance, purchasing, and suppliers, sales, marketing, and customer service. Step 2. Identify the scope of the FMEA. Is it for concept, system, design, process, or service? What are the boundaries? How detailed should we be? Use flow chart to identify the scope and to make sure every team member understands it in detail. Step 3. Fill in the identifying information at the top of your FMEA form. The remaining steps ask for information that will go into the columns of the form. Step 4. Identify the functions of your scope. Ask, what is the purpose of this system, design, process, or service? What do our customers expect it to do? Name it with a verb followed by a noun. Usually one will break the scope into separate subsystems, items, parts, assemblies, or process steps and identify the function of each. Step 5. For each function, identify all the ways failure could happen. These are potential failure modes. If necessary, go back and rewrite the function with more detail to be sure the failure modes show a loss of that function. Step 6. For each failure mode, identify all the consequences on the system, related systems, process, related processes, product, service, customer, or regulations. These are potential effects of failure. Ask, what does the customer experience because of this failure? What happens when this failure occurs? Step 7. Determine how serious each effect is. This is the severity rating, or S. Severity is usually rated on a scale from 1 to 10, where 1 is insignificant and 10 is catastrophic. If a failure mode has more than one effect, write on the FMEA table only the highest severity rating for that failure mode. Step 8. For each failure mode, determine all the potential root causes. Use tools classified as cause analysis tools, as well as the best knowledge and experience of the team. List all possible causes for each failure mode on the FMEA form. Step 9. For each cause, determine the occurrence rating, or O. This rating estimates the probability of failure occurring for that reason during the lifetime of your scope. Occurrence is usually rated on a scale from 1 to 10, where 1 is extremely unlikely and 10 is inevitable. On the FMEA table, list the occurrence rating for each cause. Step 10. For each cause, identify current process controls. These are tests, procedures or mechanisms that you now have in place to keep failures from reaching the customer. These controls might prevent the cause from happening, reduce the likelihood that it will happen, or detect failure after the cause has already happened but before the customer is affected. Step 11. For each control, determine the detection rating, or D. This rating estimates how well the controls can detect either the cause or its failure mode after they have happened but before the customer is affected. Detection is usually rated on a scale from 1 to 10, where 1 means the control is absolutely certain to detect the problem and 10 means the control is certain not to detect the problem, or no control exists. On the FMEA table, list the detection rating for each cause. Step 12. Optional for most industries. Ask, is this failure mode associated with a critical characteristic? Critical characteristics are measurements or indicators that reflect safety or compliance with government regulations and need special controls. If so, a column labeled Classification receives a Y or N to show whether special controls are needed. Usually, critical characteristics have a severity of 9 or 10 and occurrence and detection ratings above 3. Step 13. Calculate the risk priority number, or RPN, which equals S times O times D. Also calculate criticality by multiplying severity by occurrence, S times O. These numbers provide guidance for ranking potential failures in the order they should be addressed. Step 14. Identify recommended actions. These actions may be design or process changes to lower severity or occurrence. They may be additional controls to improve detection. Also note who is responsible for the actions and target completion dates. Step 15. As actions are completed, note results and the date on the FMEA form. Also, note new S, O, and D ratings and new RPNs. FMEA has the following benefits: multiple choices for mitigating the risk, higher capability of verification and validation of changes, collaboration between design of the product and process, improved design for manufacturing and assembly, lower cost solutions, legacy, tribal knowledge, and standard work utilization. Example. In this example we are performing FMEA on ATM machines. The two processes that we will be focusing on are ATM PIN authentication and dispense cash. So according to first step we will check what can go wrong and write it down. Here we wrote some major problems that could occur in each process. Next, we find the potential failure effects of those major problems and write them down. In the severity column we will give each of the potential failure effect a number depending upon how serious each effect is. Next, we find the potential causes for each major failure and in the occurrence column give it a number depending upon the probability of its occurrence. After that we look at the current process controls that are present to detect the major failure and give it a number depending upon the probability of detection of major failure. Multiply values of severity, occurrence and detection to find RPN number. Last, write the action recommended for rectifying the problem with highest RPN. This concludes the example 1. After performing the recommended action, we once again perform FMEA to check if the RPN number has improved or if any new major problem has arisen.